Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at part 2 of the guided notes on simplifying algebraic expressions using like terms, and that's going to take us right to the beginning of the second page. So go ahead and follow along with me here. Second page. I have 6 examples typed up for you. Let's take a look at each of these carefully and make sure we understand the math that's going on. Yesterday, or last video, we talked about like terms. Terms that have the exact same variable and how you can add them together. So since 4h and 16h are like terms, since they have the same variable, they can be added together. But 20h and 11 are not like terms, so this algebraic expression cannot simplify any further. Only add like terms together, not unlike terms. Now, on number 2, you can see the m over here and the m here. Well, I want to put those terms together, the 87m and the 3m, but I can't because they're not next to each other. And yes, there is this thing called the commutative property, which allows you to switch the order, but it doesn't allow you to switch the order with subtraction. So, how do I get around that? I make subtraction become adding the opposite, and that's exactly what you can do on the original problem. That's right. You would not normally do it underneath anymore. You would go adding the opposite right here on the original problem. Sorry, my adding got a little bit big there, but that's what you would do on the original problem, and then you can go ahead and switch the order to get these two terms that both have m next to each other so you can add those like terms together. Now, I know I just said add them together. You guys know when there's a positive and a negative, you subtract in your head 84m. Since 25 does not have an m, I cannot go any further because these two are not like terms. Now, what if they're already next to each other but they're not on the far left? Well, I really would like to group them with parentheses, which is called the associative property. But the associative property does not work with subtraction. So if you have subtraction, you're going to make it become adding the opposite. And like I said earlier on problem number 2, you will do the adding the opposite right on the original problem. You don't need to write it as a separate step underneath. You can do it on the original problem. And as soon as you have that, you could then draw parentheses around them on the original problem. So what I kind of separated here into 3 separate steps, you can totally do it on just the original problem. And then add the like terms together. Negative 18y, 11y, oh, negative and positive subtract in your head, and that's going to give you negative 7y. You keep the 64 on the left. But there's one more thing. We learned this on the distributive property guided notes. You cannot consider 2 symbols in between to be simplest form. So you're going to take this plus negative and you're going to write it as minus a positive. They mean the same thing because subtraction is the same as adding the opposite, but we're doing it backwards to make it look simpler. Problem number 4, x plus 9x. They are the like terms because they both have x. Now we know this 9x is 9 of the x's, but how many x's is just regular x without a coefficient to the left of it? Well, it's not 0x. Multiplicative identity tells you that 1 times x is the same as x. So when you see an x and you don't see a coefficient, that is the same as 1 times the x. And then you can say that 1x plus 9x is, should be doing the same color here, is 10x. And then obviously the 3 doesn't have an x, so they cannot be added together because they're not like terms. Problem number 5. What makes this one unique? The like terms are the 2 numbers that have no variables at all. We call numbers with no variables, we call them constants. And if you have 2 constants, they are like terms with each other. So no need to switch the order. Just group them together and add them together and get 36. Oh, by the way, I'm not going to lose sleep if you don't actually draw the parentheses. You could just add them together and I would be fine. Just don't add it to the thing that has an n because they would not be like terms. And finally, problem number 6. The reason I typed up this one for you is I want you to know that x's are not the same as y's. They're not like terms. X's are like terms with other x's. So what I did is I used the commutative property And this one already had addition in between. I didn't have to make subtraction out in the opposite because there was no subtraction here. Switch the order, get the x's next to each other, add them together. Well, once again, you're not really adding in your head. It's a negative and a positive. That's going to give you negative 3x and then plus 5y. And negative 3x and 5y, they are not like terms because they're not the same exact variable. All right, so that was 6 problems, each with something to teach you to set you up for the problems coming up next. 7, 8, 9. Now, there's a lot of problems on this page. For now, I just want you to do the next 3 problems. 7, 8, and also 9. Don't forget, make subtraction, adding the opposite. Otherwise, you're not going to be able to switch the order. You wouldn't be able to group things together either, like you saw in number 3. If you see subtraction, make it add in the opposite. That's the advice I'm going to give you. So do 7, 8, and 9, only those 3, and then hit play when you're ready to see how you did. So hit pause now, 7, 8, and 9. All right, did you already do 7, 8, and 9? If not, you better do them now and hit pause in order to do them. Here we go. 16a plus a. Well, they're already like terms next to each other, but how many a is this a? Well, it's 1a. You saw that back on problem number, 4? Yeah, number 4. So that's the multiplicative identity property in reverse. A is the same as 1 times a. But then you can say 16a plus 1a is 17a. Now, there's obviously more. 23c and 8c, they're like terms. So add them together, and you'll get 31c. Now, if you're asking yourself, Mr. Underkoffler, do I have to show the step underneath? You could have put the 1 on the A on the original problem. You could have put the parentheses on the original problem. So honestly, number 7 doesn't really need a middle step of work. You could do this middle step on the original problem, and that would be totally fine. Problem number 8. Did you make subtraction become adding the opposite? I hope you did. Otherwise, you would not have been able to do this step, where you switch the order and add the like terms, the n's, to each other. 15n, negative 28n, subtract in your head because it's a positive and a negative, and then bring down the 19w. They are not like terms, n's and w's. Problem number 9. Make subtraction adding the opposite here. Make subtraction adding the opposite here, because if you don't do that and you try to switch the order, you're going to mess up. And you're going to end up thinking you have a positive 15k when you don't. It's another negative 15k, just like there's a negative 14k. Make sure you make subtraction adding the opposite before you start to switch the order. 33 and negative 49, they are both constants, numbers with no variables, so they will get grouped together. They are like terms. So I'm kind of doing the commutative property and then also grouping, which is associative property, and I'm doing it all on one step, and I hope you're okay with me doing that. A negative plus a negative you will add in your head and get negative 29k. Positive and negative you will subtract in your head, you get negative 16. Oh, plus negative. That is not considered simplest form right there because there's 2 symbols in between. Not considered as simple as it could be written. So we're going to have to make adding a negative become subtracting a positive. We can do that because subtraction is the same as adding the opposite. We're just doing it backwards to make it look simpler. Okay, now that we went through the ones that didn't have fractions, let's look at the ones that do have fractions. And before you go, oh no, we got fractions. Look, you have a calculator. You're allowed to use the fraction key on the calculator. And just to give you a little bit of confidence, I will do number 10 with you right now before I have you do 11 and 12 on your own. So here we go, number 10. Before we do like terms, let's make subtraction become, boom, adding the opposite. Yes, you can do that even though you didn't see a number here. It would be 1x, and now it's plus negative 1x. And make subtraction adding the opposite there. Now let's go ahead and rearrange everything. The negative 3/4 h is like terms with 1/6 h. So let's put them next to each other. The negative x is like terms with the negative 7x. So let's put them next to each other. But wait a minute. Negative x is the same as negative, boom, 1x. And that's going to be an important thing to do so we can eventually add those together and know what we're going to actually get. And then the 2/3 is the only constant, meaning a number that had no variable. That is just going to have to be tagged on at the end. Now, I didn't draw parentheses here, but you totally could if you wanted to. We're going to group the h's together, and we're going to group the x's together, and then that poor 2/3 that didn't have any variable at all, it's just going to stay on the right-hand side. All right, use your calculator, and don't look for an H key. There is no H key on your calculator. In your calculator, do -3/4 plus 1/6. Do it now. It will give you -7/12. Now, write the H with it. And then, -1 and -7, a negative and a negative, you would add in your head, -a to x. And then the 2/3 is just going to stay there. We're almost done. Oh, right here. 2 symbols in between. Let's simplify that. That's going to become minus +8x. And everything else is going to stay the same. All right. Now that you know that this really isn't that bad, you still like terms having the same variables, you can use your calculator for the fraction parts. Not a big deal. Let's have you try 11, 12, and I would also like you to go further. Do 13 and 14 on your own. They don't have any fractions, but I think you should be able to do them on your own. So hit pause now. Do those last 4 problems. 11, 12, 13, and 14 on your own. Then hit play when you're ready to see how you did. All right. Did you already do 11, 12, 13, and 14? I hope you did, because I'm going to go over them right now. Make subtraction become adding the opposite here. Make it adding the opposite here. And also adding the opposite here. That's right. We had 3 places that had subtraction. Now, from here, I'm going to switch the order and put all my C's with each other. Oh, and that's right. The C here is 1C. I will eventually group these guys together. Whether or not you draw the parentheses is totally up to you. I'm not going to lose sleep if you don't. Who else do we have? 3 did not have a variable. -4/5 did not have a variable. They are 2 constants. They are like terms. I don't care the 3 doesn't have a fraction. I don't care. It has no variable, and -4/5 has no variable. That makes them like terms. All right. In your calculator, you can do 1 plus -2/5 plus -3/5. And that would give you 0C. In your calculator, do 3 plus -4/5. You would get 2 1/5. We're actually not done. You're like, what? Oh, we can go further. If you go to the very bottom of the very first page of the guided notes, 0x means 0 times x, and anything times 0 equals 0. We can use that here to do the finishing touches on problem number 11. 0 times c is 0. And 0 plus 2 1/5, this is actually called the additive identity. Anything plus 0 is itself. Boom. 2 1/5. You're like, wait a minute, what happened to the c? It was 0 times c, which is just 0. That's the only way that a variable can go abracadabra disappear. In fact, it's not abracadabra. It's not magic at all. It is math. 0 times c is 0. And that made the variable go away. And then you just add the 0 to 2 1/5, and you're done. 2 1/5. Next problem. I'm going to put all the terms that had r's next to each other. -r is -1r. This 3/5 w, it's not like the others. It's the only thing that had a w. So put these like terms together. Draw the parentheses if you want. And in your calculator, -1 plus 7/8 plus -1/3 should have given you -11/24. Put the r, and then the 3/5 w is just 3/5 w. Problem 13. Make subtraction, adding the opposite here. Make it adding the opposite here. You're like, whoa, you ignored the parentheses? Well, yeah, I did. Did you read the little hint off to the side? The parentheses don't really matter. They don't really do anything when there's only one number inside. The only reason the parentheses were there, and I did talk about this like weeks ago, is textbooks across the world wants you to know that this is a negative 13, but there's also a minus. So they'll put the negative number in parentheses when it comes to the right of a plus, minus, times, or divide. That's the only reason the parentheses were even put there. But they don't really do anything. So ignore them and make minus a negative become adding a positive. For those of you who had plus, negative, negative, don't do that. Just adding a positive. So you might need to hit pause now and fix your 13 if you didn't do this part here correctly. Let's regroup these. All the xy's are going to go next to each other, and this xy right here is 1xy. Now, group those together. But there's more like terms. The 1 and the 13, they're both constants. So they are like terms, and I'm going to group them together. All right, 7 and 1 makes 8. 8 and negative 22 would be negative 14xy. And yes, you're technically allowed to use your calculator if you really want. But don't you dare use a calculator for 1 plus 13. That's just simply 14. Do not go further. I know you see a negative 14 and a positive 14, and you're probably thinking, ooh, can I make it 0? Nope, 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 you can't. The negative 14 has an xy. The positive 14 does not. So they are not like terms. Do not add them together. All right, number 14. We had lots of variables that had no numbers, no coefficients on them. Hopefully you know that p is the same as 1p. And there's another p right here. Oh, but there's minus. Did you make subtraction become adding the opposite here? And adding the opposite here. And adding the opposite here. And adding the opposite here. I know it's getting a little annoying here, but lots of subtraction. All right, p and negative 10p, they are like terms. 4q, negative 5q. Oh, and I almost forgot this q right here, which is 1q. All those q's together are like terms. And I'm about to get a little creative here. Instead of drawing parentheses, I'm kind of drawing some little diagonal lines to show you what I'm about to get, like 1p and negative 10p is negative 9p. You could draw parentheses if you'd rather. That's fine. And then the pq's. Negative 6pq is like terms with negative pq, which is negative 1pq. All right, 1q and 4q is 5q, plus negative 5q is 0q. Negative 6pq and negative 1pq is negative 7pq. There is something you can simplify. 0q is the same as 0, and there's more. Let me get out my highlighter here. Plus negative is not considered simplest form, so you're going to transform that into minus a positive 7pq. And I'm not done. Anything plus 0 is itself, so negative 9p plus 0 is just negative 9p, and then minus 7pq, and that is the simplified version of number 14. All right, I'm going to stop this video here. The last page of word problems and geometry problems I will do as a separate video. Thank you for watching. We'll see you next time.